For D, this is simply knowledge. Explain why the petroleum industry processes straight-chain alkanes into cyclic ones. The reason for this is that it's smoother and more efficient burning. The next question is asking us about hydrocarbon C and how it can be processed into the cyclic hydrocarbon B. So what I would do here is I would look at my structures that were given to me on the previous page. Hydrocarbon C, I've got this by counting the carbons and hydrogens from the diagram. It then tells me that it's turned into the cyclic hydrocarbon B, so I looked at hydrocarbon B and added these up again from the diagram. The difference between these two structures is a simple 2 hydrogens, therefore it is hydrogen that must be released when we have this process occurring. It's also important to note that this is what's left over, and also it's very common when you have formation of cyclic hydrocarbons, hydrogen will be released. The next question is asking us about boiling points. Whenever you have a question on boiling points, you know you must refer to forces. So explain why hydrocarbon D has a higher boiling point than hydrocarbon C. If we have a higher boiling point, it means that we have more forces, and you have to be aware of what type of forces in each case we have got more of. In this case, because D is a bigger molecule than C is, it's quite simply, it has more London forces. So there are greater London forces because we have a bigger molecule, and therefore we have a greater number of electrons. F, what is meant by stereoisomerism? Now, a lot of students get this wrong because instead of saying that they have the same structural formula and a different arrangement in space, they say they have the same molecular formula. This is true, they do have the same molecular formula, but that is not enough. You have to say it is the same structural formula and a different arrangement of atoms in space.